Welcome everyone to the Spring Impact Update. We're going to go ahead and get started. A couple quick notes of housekeeping. This webinar is being recorded, and I'll present for about 45 minutes, then we'll have an opportunity at the end for Q&A. But if anyone does have questions along the way, please feel free to send them in via the Q&A button, and I will do my best to answer all of them at the end. We've got an hour allotted, but can go later than an hour if there are additional questions. And of course, if there are any additional questions after the webinar, if you have any questions, feedback, please get in touch at support@chordoma.org. And this webinar will be available online on YouTube in the coming days. So I am really grateful to be here. By a quick way of background, my name is Josh Sommer. I'm co-founder and executive director of the Chordoma Foundation, a now 17-year chordoma survivor. Was diagnosed at the age of 18 back in 2006, and was very fortunate to have a wonderful and very successful operation. Remained tumor-free for 16 years. And then, much to my surprise, ended up having a recurrence last year, right around my 16-year anniversary. Was fortunate to once again undergo surgery last August. Made it through surgery in good form. And then just a couple months later, we welcomed our second child, who is now, as of today, 6 months old. And feeling so grateful to be here, and so encouraged by the progress that's being made, which I look forward to sharing with you over the course of this webinar. So by quick way of background, I think for those maybe who are new to this community, the mission of the Chordoma Foundation is to improve the lives of those affected by chordoma and to lead the search for a cure. And we do that by pursuing three goals: better treatments, better care, and a better experience for everyone who is affected by this disease. Our ultimate vision is for everyone affected by this disease to be able to overcome the disease and maintain their quality of life. All of these efforts are really critical and mutually reinforcing. But today I'm going to be focusing on research progress. So a quick background here, probably for those of you who are patients, it will come as no surprise that we really believe that better treatments are critical. It is certainly the case that surgery and radiation have become extraordinarily advanced, and I'm sure many of you on the webinar are a living testament to that. They can be exceedingly effective in the initial treatment setting. Some patients, probably about 40 or 50% of patients who receive optimal treatment, can go on and be cured of their disease. However, not everyone gets appropriate treatment at the outset, and there's a lot that needs to be done to help more patients get the right treatment up front, and that's what our patient services and healthcare improvement efforts are about. But even with the best treatment possible, many patients ultimately experience recurrences. Sometimes those recurrences can be dealt with. If they are truly a localized recurrence, they can be dealt with effectively with surgery and radiation, and patients again can go on and lead full lives, if not be cured. However, the majority of patients who experience local recurrence, the disease cannot be controlled with surgery and radiation, and ultimately they experience additional recurrences. Perhaps the disease spreads regionally, or they develop distant metastases, and eventually surgery and radiation are no longer options. And unfortunately for patients with advanced disease, at this moment, there really are no curative therapies, and eventually, essentially most patients in this setting ultimately succumb to the disease. At the same time, chordoma takes a toll on patients' quality of life. There are a wide range of health effects, of morbidities and challenges that patients face, and it really varies based upon the location of the tumor. But suffice it to say, current treatments are inadequate, and that they are leaving many in this community with significant quality of life impact. So what we believe is that better treatments are urgently needed, treatments that can improve and preserve quality of life, treatments that can permanently stop the progression of the disease, and ultimately treatments that can increase survival. So we would like to turn this into a disease that at any stage, whether you have advanced disease, local recurrence, or initial treatment, that there are treatments available that can stop progression and improve or maintain quality of life. So as I mentioned, surgery and radiation have become quite advanced. It's really remarkable what can be accomplished with those modalities. I'm just in complete awe of what my own surgical team was able to do to remove my tumor off of my brainstem and from near arteries and nerves. It's truly remarkable. However, even the world's best surgeons and radiation oncologists will tell you that surgery and radiation are never going to be the entire answer because of where this tumor is located on critical structures like nerves and the spinal cord, brainstem, et cetera. You're never going to be able to, in all cases, get negative margins. And so there's always, to some extent, going to be, in many patients at least, tumor left behind. And what's really missing for chordoma is an effective systemic therapy, the third leg of the stool, so to speak. Radiation and surgery are quite good, but effective systemic therapies are largely missing for this disease. So here you can see all of these systemic therapies that have been tested in clinical trials. And the response rates are really quite mediocre, to say the least. Now, granted, this is response rate. This is tumors shrinking. There can be benefit derived from tumors stabilizing or not progressing, and some of these therapies do indeed induce stabilization for some period of time. However, that's really not good enough. There is a need for systemic therapies that can more durably control recurrent or advanced disease. And that's really where the focus is at the outset. However, systemic therapies also could play a role in combination with surgery and radiation to increase their effectiveness and perhaps reduce the rate of recurrence. One potential setting or use for systemic therapy is to actually shrink a tumor prior to surgery and radiation, thereby enabling surgery and radiation to be more successful. Perhaps eventually, systemic therapy could offer a safer and more effective alternative to surgery and radiation to avoid some of the significant quality of life impacts that many patients experience with those modalities. So on the one hand, you could look at that list and find it depressing. Here we've more than a dozen therapies have been tested for chordoma. The response rates are really not that great. But I look at that list and actually see tremendous opportunity. Those therapies represent a very, very, very small slice of the universe of potential therapies that are available to patients. And for the most part, those trials were designed and initiated prior to us having a strong understanding of the biology of the disease. And we have seen time and time again for other tumor types that with a strong mechanistic understanding and with a good hypothesis, it really is possible to achieve significant response rates when you've matched the right therapy with the right underlying mechanism of disease. So we don't know at the outset exactly what the specific path to better treatments is going to be. But one thing we do know for sure is that almost certainly chordoma is going to require multiple systemic therapies. There are very, very few cancers that are controlled with just one therapy. It's possible that combinations will be required. It's possible that therapies will need to be used sequentially if resistance develops to one. It's also very likely that there are different molecular subtypes of this disease. And so perhaps with the exception of therapies targeting brachyury, which I'll talk about later, it's much more likely that there will need to be a kind of a toolbox of different therapies that are applied to different subsets of the patient population based upon the specific biology of their disease. So we need multiple shots on goal. We need to pursue multiple systemic therapies, and they can come from several places. They could come from the more than 3,000 drugs that are already approved and could be prescribed off-label tomorrow. They could come from the roughly 7,000 drugs that are in development across the world, or they could come from a new drug that hasn't yet been developed, but the technologies and approaches to enable new drug development against targets that historically have been difficult or undruggable is really rapidly advancing. And there's some incredibly powerful new modalities that represent opportunities for this disease. So while we don't know exactly where the cure or cures will come from, what we can say with great certainty is that the path or paths will traverse a certain set of key areas of research. So ultimately, in order to guide clinical care, you need to see evidence that the drug works in the clinical setting, in clinical trials. In order to initiate and design and attract funding for clinical trials and be able to get ethics approval for clinical trials, you have to have a strong case, a strong data package, and a well-designed trial that's based upon an understanding of the biology of the disease, and ideally an understanding of whether this disease works in preclinical models of the disease, so cells and animal models of chordoma. It may be the case that for repurposed or repositioned drugs that this translational research, generating that preclinical data, can be done with drugs that are already accessible. However, depending upon where the biology leads us, if it leads us to a target for chordoma that is not currently druggable, then we may have to embark in new drug discovery. But we don't know which of those paths will need to be taken until we understand the biology of the disease, until we have a deep mechanistic understanding of what drives the tumor and what its vulnerabilities are. And that's where target discovery research comes in. In order to enable target discovery research, in order to enable drug discovery, in order to enable translational research, it's critical to have a set of critical resources, so biospecimens, models, data, et cetera. And it's progress in any one of these areas is necessary but not sufficient. We really need progress, rapid progress across this entire continuum to improve care on a timescale that matters to patients that are alive today. So I'm going to run through this continuum and talk about progress that's been made in each of these areas and what the current opportunities are in each of these areas of research. So when the foundation started about 16 years ago, we were really starting from square one. The basic research enabling resources that were needed to do any meaningful research were simply lacking. And that posed a major barrier to research in any lab that might be interested in chordoma. So that was really the problem that needed to be attacked first. And over the last 15 years or so, through a lot of investment and a lot of work on behalf of many investigators across the world, we've largely overcome that challenge. So we now have access, we now have made accessible to the research community a wide variety of these critical resources. They are available through open access repositories. And so now if you're a researcher or a company that becomes interested in chordoma, it is not only do those resources exist, but it has become very easy to access them without having to go search around and request them from lots of different institutions, which is unfortunately the norm in research. So this has been a long-term effort, and it continues. So just in the last several months, we've added to this resource repository. We've developed what's called a tissue microarray. And so that takes tumor tissue that's already been banked and puts it on a slide. And so rather than having to study one tumor at a time, now researchers can study about 95 tumors all at once with basically a single experiment. So this is contributing to increasing the speed and efficiency of research. We've also completed genomic profiling of quite a number of cell lines and mouse models and made that data easily accessible to the research community. And we've also centralized that data along with other genomic data into an easy to query online portal. So now it is really become trivial for researchers to ask questions about these models and select models that represent different subsets of the disease that might be relevant to different drugs. So all of that together has really broadened the range of research that's possible for this disease, and by creating kind of this feasible research ecosystem or a conducive research ecosystem, we've been able to attract numerous researchers from across the globe to study this disease. So in total now there's over 300 researchers. We've funded research in several dozen labs across the world. We've provided cell lines to over 100 labs across the world. And a lot of that research is focused on basically understanding what makes chordoma tick and trying to apply the full complement of the most advanced techniques and technologies to understand in an unbiased fashion what is driving this disease, and to develop a kind of a multi-layered map, if you will, of the biology of chordoma. So our grantees have applied quite a number of cutting edge technologies, and this has led to the discovery of about 45 potential therapeutic targets, a number of which are currently druggable. So that means that there are approved drugs or drugs that are in development that could be applicable to chordoma. One of them is a currently undruggable target. It is a protein called brachyury, which actually seems to be perhaps the most critical or the most promising target for the disease. And so that has pointed us to a need to invest in discovering drugs against brachyury. And I'll come back to that momentarily. But I just want to highlight a really exciting development that has emerged from a long-term collaboration with our grantees at the Broad Institute, led by Dr. Stuart Schreiber. Much of this work was spearheaded by an incredibly talented research scientist, Tanaz Sharifnia, as well as Matthias Wewar. And so what they did is they, rather than kind of searching one gene at a time for kind of what chordoma might depend on for its survival, they employed a cutting edge technology called genome-wide CRISPR loss of function screens. So you might have heard about CRISPR in the news. It's this incredibly powerful genetic engineering technology, and it has a tremendous number of applications. But one application is that you can use CRISPR to essentially knock out or incapacitate every single gene in the genome one at a time. And you can ask the question, which of those genes does chordoma depend upon for its survival? And so this is a really massive undertaking. At the time that this project was started, this had really been done for only a handful of cancers. And chordoma was kind of towards the front of the line. This approach was, the Broad Institute was really one of the early leaders in applying this approach to cancer. And so we've been collaborating with this group for a number of years now. And just this month, they came out with a very high profile publication that reported about a dozen genetic essentialities in chordoma. So that means genes that chordoma is highly dependent upon for its survival or proliferation. And in particular, genes that chordoma is uniquely dependent upon. So these are genes that are perhaps not as important in other tumor types or as important in normal tissues. Here you can see denoted in red, these are genes that are already targetable with existing drugs. And then here you could also see a number of genes that are not currently targetable, and that perhaps motivates future drug discovery efforts. In addition to that exciting recent development, just in the last couple of weeks, we have awarded a grant to a research team in Germany. This is actually an extension of a project that we began funding in 2020. And they are they are attempting to build essentially the most complete integrated multi-layer picture of chordoma biology. This is an approach called multi-omics. So looking at all the changes in DNA, the changes in gene expression, changes in protein, et cetera. And with the ultimate goal here of developing a large enough or analyzing a large enough cohort of patients that you can really start to zero in on molecular subtypes of the disease and identify which targets are relevant to those different subtypes. Additionally, what's really great about this project is we are leveraging a nationwide prospective protocol in Germany called the Master Protocol, whereby patients all over the country are enrolled onto this study. They are treated with molecularly guided therapy. Then their tumors are collected. And so what that means is that we actually, in this study, there are quite a number of patients who have been treated with various systemic therapies. And that allows the team to ask the question, are there aspects of the tumors that might be associated with or predictive of response to different systemic therapies? And with the ultimate goal of helping to identify biomarkers that could guide future use of various systemic therapies. So thanks to the generosity of a number of donors in the community, we've just recently provided supplemental funding to expand the cohort, as well as to add additional layers of data to the analysis that they're performing. Okay, so a couple recent encouraging milestones on the target discovery front. There are about a half dozen other projects that are ongoing right now, and more projects that will need to begin in the coming months as new opportunities arise and as new technologies emerge. In parallel, in the last several years, the case that for brachyury as being an important drug target has become so strong, even though it is a challenging drug target, even though it has historically been considered undruggable, it's become so strong that really it has become imperative that we take on brachyury drug discovery. So a quick kind of snapshot of why we believe brachyury is so important. Number one, there is multiple layers of evidence that indicates that brachyury is critical for driving chordoma initiation and progression. There are a number of complementary data points that show that brachyury is essential for chordoma cell proliferation and survival. And here you can see two graphs that make that point. So in the center of the screen here, what you're looking at is on the top. This is the growth of cells that are essentially untreated. And then on the bottom here, these are cells that have brachyury, the gene expression suppressed using a genetic tool in the lab. And here you can see that it really significantly stops and curtails the growth of these cells. On the right panel here, what you're looking at is a result of that project at the Broad Institute that I mentioned, whereby they compared how essential every single gene in the chordoma genome is to other tumor types. And you can see here, the y-axis is the relative essentiality, how important the gene is in chordoma compared to other tumor types. And brachyury here is a huge outlier. So each of these data points is a different gene. And so, if ever there was a smoking gun that there was a gene important for a disease, this is it. What is quite advantageous is that brachyury is very minimally expressed in just a handful of normal tissues after development. And so what that would imply is that a therapy that could target brachyury would have an impact on the tumor, but most likely would be expected to not have an impact on normal tissue. So clearly a big opportunity, but for a number of reasons, brachyury has represented a challenging drug target. However, in the past decade or so, there has been a confluence of new approaches and technologies that for the first time make it conceivable to develop drugs against the type of target that brachyury represents. And so beginning
about 5 or 6 years ago, we started funding a series of projects at a handful of institutions across the world. First, to develop the enabling research tools to make it possible to study brachyury and to pursue brachyury drug discovery, and importantly, to make those tools easily accessible to the research community, unencumbered by patents or IP or onerous material transfer agreements that oftentimes really impede research on new targets like this. The work that we've supported has employed several different approaches, or has sought to develop several different classes of therapies targeting brachyury. So some including small molecules. These are basically drugs that you would that interfere with the function of the protein. Some are a new class of therapies called degraders, which actually take advantage of an intrinsic function within the cell to degrade or eliminate unneeded or deleterious proteins. So basically send the brachyury protein to the metaphorical wood chipper or garbage disposal in the cell. And then another approach called antisense, which interferes with the production of the brachyury protein. So all of these efforts are ongoing in multiple different labs, as well as encouragingly several different companies now. The centerpiece of our efforts has been a really massive, truly unprecedented industrial scale drug discovery effort. And what's unprecedented about it, A, is the scale, and B, is that it is completely out in the open. So the idea is, we were starting essentially in our own end zone with no compounds that even bound to the brachyury protein. And historically or conventionally within the world of drug discovery, everyone is competing, and that requires building the same infrastructure, doing the same chemistry. Everyone's competing from essentially from one end zone to the other. We said, well, what if we could help everyone basically get to the 50-yard line with a set of tool compounds that we know bind to the brachyury protein, could be used to study the brachyury protein in cells, but that could be used as advanced templates for drug discovery, and then allow researchers and companies to compete from the 50-yard line, let's say, without having to recreate the wheel and kind of retrace the same steps and frankly make the same mistakes at the earliest and most risky stages of drug discovery. So we've partnered with two other foundations, the Mark Foundation for Cancer Research, as well as the Marcus Foundation, and together have invested over $2 million to apply a number of different approaches to develop such compounds. And I'm really happy to say that this has yielded quite a number of promising chemical series. So groups of compounds that have the properties that are needed to begin the actual drug discovery process. So these are compounds that are not themselves drugs, but that are scaffolds, if you will, or templates that bind to the brachyury protein, and they can be further optimized to either impede its function or to develop degraders, which I mentioned earlier, to cause it to basically be destroyed. So really promising advances here. We've kind of come miles from where we started a few years ago. There's still more work to be done, but I think as a patient and as someone who perhaps stands to benefit from the emergence of brachyury therapies, this is a tremendous source of hope and encouragement. So while the brachyury work has been ongoing, as I mentioned, there are about 45 potential therapeutic targets that are tractable, so for which there are existing drugs that could be applied to chordoma. And the goal has been to test those systematically in preclinical models of chordoma to develop the preclinical data packages that are necessary to justify clinical trials. And we started doing this about 10 years ago now. And what we soon or kind of quickly realized was that the pace of progress for this sort of translational research to go from target discovery to data sufficient to justify clinical trial was far too slow in an academic setting to match the urgent need that we as patients have. And to put this in perspective, in all of history, so from up until present, about 10 drugs have ever been tested in chordoma mouse models within the context of academia, and 0 have been tested in companies. This is a project we began funding back in 2012, and the results were only published 9 years later in 2021. So clearly, if you're a patient and you have an urgent need for better therapies, that timeline does not cut it. And so we sought to understand why is it that this is so slow and what can be done to make it faster. So the reality is that, perhaps not unsurprisingly, chordoma is a rare disease. Few of the researchers who have knowledge of relevant drugs, signaling pathways, or kind of cutting edge approaches start off with experience doing chordoma research. What that means is that to go from a standing start to actually testing drugs in your lab requires significant startup time and cost. You have to import cell lines and mouse models. You have to train up people in your lab. There's a significant startup period. So that's a significant barrier to entry. Once that is overcome, so once a lab has started chordoma research and developed those capabilities, sometimes it makes sense to collaborate, but there are, unfortunately, the reality is there are a number of barriers to streamlined collaboration between academic labs, and even greater barriers to collaboration between academic labs and companies. And so oftentimes those barriers become insurmountable, and what that leads to is multiple labs duplicating the same capabilities, unfortunately. When those capabilities are created, the reality is that each lab tends to focus on a relatively small set of therapeutic concepts or approaches that correspond to their interest or area of expertise. And that means that these capabilities that are established to test drugs in cells and mice, for example, are utilized in a low throughput fashion, which leads to lower than possible efficiency, essentially missing out on economies of scale. Once the data is generated, researchers have a strong incentive to use that data to maximize the academic credit that can be derived, specifically to publish and to publish in high impact journals. And that oftentimes requires developing an elegant and academically interesting story that is suitable for publication. And that can take years and years. So oftentimes data will be generated early on in the course of a project. And then it has to be paired with a whole series of results from other experiments that could take years, oftentimes many years, to generate. And so the data that's generated early in the project might sit for years without actually ever seeing the light of day. And that poses a major problem if you're a patient. So if you're an academic researcher, this makes sense. Eventually the data gets published and you get academic credit, you get your publications, and that's critical for career advancement. And this is not, this is the reality. It's not to throw stones or fault anyone. This is the reality of what it means to be an academic researcher. But if you're a patient, you don't care about publications. You care about the data being made available to other researchers and or companies who could build upon it and ultimately initiate clinical trials. And then finally, sometimes the best ideas come from researchers that don't have the capabilities to do experiments on their own. Maybe it's a medical oncologist that doesn't have their own lab. And so good ideas go nowhere simply because they happen to be conceived of by a researcher who wasn't in the right institution or didn't have the right capabilities. So to solve those problems, we recognized that there was a need for a more efficient and more rapid way of doing this preclinical research. So here what you can see is the typical process that I just described, charted on a time scale. So there's a long startup period, then you do the experiments, and then you wait to publish, and ultimately years can transpire. Beginning in about 2014, we set up a centralized drug screening program whereby a collection of chordoma mouse models are constantly at the ready to be tested within a contract lab. And what that means is that we don't have to, we've gone through the startup process. We don't have to do that every time a new idea comes. The models are basically always warm and always just a couple months away from being ready for an experiment. The experiments themselves take about the same amount of time. You can't really condense the length of the experiment, but what you can do is batch different experiments so that they can be done more efficiently and the unit cost can come down. And in some cases, when we collaborate with an academic or a company, we need to respect the confidentiality the confidentiality terms of that collaboration. And sometimes we do have to embargo results. That means we can't share them until they end up in a publication or a presentation at a conference. But oftentimes, some of the concepts that are run through this drug screening program are internally conceived concepts. They either come from our scientific staff or from our medical or scientific advisors. And in those cases, we have no obligations to third parties and can make the data available publicly to our medical advisory board, et cetera, in real time. And so we're able to go from results to clinical trial concept in basically instantaneously, oftentimes skipping the need to publish. And I'll just say that this is not to say that publication is not important. Eventually, these results should be published and will be published, and the peer review process is important. But that shouldn't be gating to sharing results, for example, with a company that for whom those results could spur investment in a clinical trial. So we've seen that by setting up those capabilities, by setting up that ability to test drugs in mice, it's been incredibly catalytic, and I'll talk about some of the impact momentarily. But what we observed was that there was a need for capabilities beyond just testing drugs in mice. Even to be able to effectively design experiments in mice, there was a whole series of cell-based experiments that were needed. Needed to be able to validate therapeutic targets before making the decision to invest in testing drugs in mice. When we got results from mice, there were further tests in cells that were needed to interpret them and to effectively design clinical trials. And because those capabilities we didn't have an easy way of doing those experiments, what we were finding was that sometimes concepts were getting stalled or stuck. Additionally, what we were finding was that a number of our research collaborators or partners had ideas that they wanted to pursue, but again, the barrier to entry or the activation energy was too high or too costly for them to pursue those projects efficiently in their own labs. So last year, we kind of expanded the concept of the in vivo, the mouse-based experiments, and added the capabilities to do a wide variety of cell-based experiments in our own lab. So we set up what we call Chordoma Foundation Labs. This is the only lab in the world that's 100% dedicated to chordoma research. We specialize in running a standardized set, a common set of experiments in chordoma cells that are needed by a wide variety of different researchers. And what this allows us to do is partner with researchers who are experts in leading edge technologies, approaches, aspects of biology, who have no previous experience with chordoma and for whom chordoma might never be a focus of their lab, but nonetheless have a critical capability or expertise that we want to help bring to bear on chordoma. And we can form a very synergistic partnership whereby they provide their expertise and perhaps do bespoke or sophisticated experiments that only their lab can do. And then we handle the kind of the more bread and butter experiments that many labs need to do in chordoma cells. So this allows us to de-risk many projects that would otherwise be infeasible for both academics and companies. And at the same time, it gives us the ability to use those capabilities that we make available to the research community, but also use them to pursue research of our own, unconstrained or unencumbered by the incentives of academia and industry, i.e. the need to publish or derive profit. And that opens up an entire universe of research that historically has been impossible or infeasible to pursue. So the results of this are, I think, just extraordinarily impactful. As I mentioned, 10 drugs to date tested in academic labs, 0 in companies. Through our drug screening program, we've now tested more than 80 drugs on behalf of more than 36 collaborators. This has led to 10 therapeutic concepts that our medical advisory board has endorsed for clinical evaluation. In the past year, so of those 80, we were working on 25 of them in the past year. And importantly, we just brought online the ability to test drugs in a new type of model that is suitable for testing immunotherapies, which are a very promising category of therapies for chordoma. And just in the last quarter, 4 new concepts that have gone through this pipeline have been endorsed for clinical evaluation by the medical advisory board. I want to run through a couple notable vignettes here. So evidence from our collaborators at the University of Heidelberg, as well as at the Broad Institute, pointed to a kind of an interesting aspect of chordoma biology, that essentially chordomas have the hallmarks of this phenomenon called replication stress, whereby chordomas have a hard time dividing, when they divide, replicating their DNA. And in other tumor types, that has pointed to a number of different therapeutic strategies that could exploit that phenomenon of replication stress. One of our medical advisory board members, Dr. Greg Cote, is a medical oncologist at Mass General, proposed to us that we test therapies that could target replication stress. Dr. Cote does not have a lab of his own, but we partnered with him to test a number of, a couple of drugs that exploit replication stress, both in cells as well as in mouse models. And we were able to do this within the span of less than a year. So in total, we tested 2 drugs in 14 chordoma cell lines, which, by the way, is pretty unprecedented. Most of the time, research is done in 3-4 cell lines, perhaps. But within chordoma labs, we've amassed the largest collection of chordoma cell lines everywhere. And much to our delight, we see that both of these drugs that target replication stress are highly active in the majority of chordoma cell lines. In particular, the drug gemcitabine, which, by the way, is an old chemotherapy drug approved in 1996. It was exquisitely active in chordoma cells. And if you compare chordoma to about 1,000 other chordoma cell lines to about 1,000 other cell lines in which gemcitabine has been tested, here you can see chordomas are outliers in terms of their sensitivity to this drug. So very promising signal. Again, we were able to take these findings. We didn't have to wait on anyone to publish. We were able to go straight from cells into mouse models. And again, within the span of a few months, demonstrate that indeed both of these therapies, gemcitabine and elamusertib, are highly active in a number of chordoma mouse models. Now, granted, this is representative panel. We tested it in additional mouse models. Not all of them are as sensitive. And so that actually provides some interesting clues, or perhaps starting points for further research that's already begun in the lab to try to identify predictors of which models might be sensitive and which aren't sensitive. And that could perhaps guide future clinical trials to know which patients might benefit and which might not. So I just want to highlight here that a couple of these results in 2 of these models, of the 80 drugs roughly that have been tested, this is the most dramatic response we've seen in mouse models. So based upon this data, our medical advisory board endorsed evaluating this drug clinically, and we know that several oncologists now are providing this drug to their patients off-label. Very exciting milestone. Just last week, our research team, Dr. Dan Freed, Nindo Punturi, and Lee Jolat from the lab, they went down to Orlando to the American Association of Cancer Research annual conference and presented 2 posters, one summarizing the results that I just shared about replication stress in chordoma, and then another poster presenting a project out of CF Labs in which we've been trying to identify factors that might predict response or non-response to a class of therapies called EGFR inhibitors. You may have heard of afatinib or erlotinib or cetuximab. These are drugs that are in clinical trials or have been used off-label for chordoma with some success. And we've got some very interesting hints about what might be driving response or resistance to various EGFR inhibitors. I'll just say that this is notable in that we've contributed data to posters that have been at AACR as well as other conferences in the past, but this is the first time that that we have presented research that we have led, and to our knowledge, this is actually unprecedented. This is the first time that any patient-driven organization has ever presented at AACR or a comparable professional society. So truly a new model of doing research, whereby for the first time, we are no longer dependent upon others whose interests or incentives may not exactly align with ours. But as patients, we now have, really for the first time, the ability to have a much greater control, a much greater influence over our own destiny. So because of what's happening in CF Labs, because of the culmination of investments in target discovery research and everything I've talked about to date, there has been a proliferation of new clinical trials in recent years. So basically for the 6 years up until last year, we averaged initiating one new clinical trial per year. And encouragingly, 4 of these clinical trials actually have completed enrollment just in the last year or so, and results will be forthcoming. Several of these trials will be presented at our upcoming research workshop, but we expect that either later this year or early next year, results from these trials will be published and very well have the potential to influence treatment options going forward. However, last year, we went from 1 new trial to 3 new trials initiated, and all of these were based upon preclinical data that was generated either in CF Labs or the drug screening program. And encouragingly now, there are 4 new therapies, 4 new concepts that the Medical Advisory Board has endorsed that we're now working to initiate clinical trials around. We recognize, though, that we need to do better in terms of enabling trials to get started quickly, to make it easier for patients to enroll in trials, to make trials faster and more efficient. The reality is that while we've done a lot to enable trials to proceed relatively quickly compared to other rare cancers, there's still more work to be done. And one of the big barriers that needed to be overcome was the challenge that travel posed to patients. So some of you may be aware, last year we initiated or supported the initiation of a trial at MD Anderson with a drug called cetuximab, an EGFR inhibitor that was identified through the drug screening program. And patients have to travel to this trial roughly every 2 weeks. There are patients who are participating from 8 different states, and they have to travel to Houston pretty frequently. This is a huge logistical and financial burden. And we recognize that unless we were able to help patients overcome that burden, it was going to be very difficult for patients to participate and for that trial to be a success. So thanks to the generosity of many in this community, we started last year our clinical trial assistance program and have been able to provide assistance to 8 of the first 10 patients who participated on that trial. For all of those patients, that this assistance was critical to their participation, so they wouldn't have been able to join without it. And as a result, the trial accrued those first 10 patients, which was the first stage of the trial, in record time, in less than 3 months, compared to perhaps 6 or 9 months that the investigators were expecting. And in those first 10 patients, if at least 1 patient benefited, then it would go on to enroll an additional 19 patients. And indeed, at least 1 patient has benefited. And so now the trial is opening to an additional 19 patients. And however, we are now being leaned upon to come up with the funds to be able to support the next stage of that trial. So huge priority for us right now is to fund the second stage of this trial, as well as to continue funding the trial assistance program for patients who are participating. I also just want to call attention to a new resource on our website. So if anyone is currently in need of a systemic therapy, we've just rolled out, you may be aware, a new website, and in particular, a new resource on the website, drug therapy options. So this lists all of the drugs that are available to chordoma patients, either off-label or or on clinical trials. And if anyone has an interest, please, I encourage you to go check this out, or to contact our patient navigators at support@chordoma.org. So tremendous amount of momentum. Where are we going now? I just want to briefly summarize current needs and priorities. So on resource development, there's still some remaining gaps that need to be filled in chordoma models, and we're working diligently to try to come up with the resources to fill those gaps so that we ensure that the preclinical research that's being done is relevant to the entire chordoma patient population. There are a couple additional target discovery projects that are essentially shovel ready. One at MD Anderson, one at further continuation of this work in Heidelberg that I mentioned. In Q3 of this year, we're expecting to have a couple new immunotherapy projects that are currently being peer reviewed right now. And the great thing about these projects is that it's a joint grant program with the Cancer Research Institute. So our funding is matched dollar for dollar. And then after the upcoming research workshop, our hope is to, we know that there's always a tremendous amount of new ideas that emerge from the research workshops. We want to put out a request for proposals and be ready with the funds to be able to fund those proposals as new ideas come in. We are in the process of standing up a prize to incentivize very specific important work in brachyury drug discovery. As I mentioned, there's several different drug companies that have become interested in brachyury now, and through CF Labs, there are a series of in-kind services or capabilities that those companies need, and we need to be there as a partner to provide those capabilities to enable preclinical development of brachyury drugs. And we are approaching the point now of where several of these companies might require venture philanthropy, so essentially monetary support from the Chordoma Foundation to be able to prioritize work on brachyury over, let's say, other targets that might be more lucrative. Right now, there are 12 projects in our queue in CF Labs. So 9 projects have started, 2 have completed, 7 are ongoing, 12 more projects that are just waiting for bandwidth to free up. So urgent need for more bandwidth in the lab. And what we've seen is that when we have the capacity, we can move with unprecedented speed. And as the gemcitabine example illustrated. And then additionally, we have a number of drugs that are in the queue for testing in vivo, and we need to continue investing in that as well. We've got to move on to the second stage of the Stuxmab trial. We've got to come up with funds and be able to support those 4 upcoming clinical trials that I mentioned. And then there are a number of opportunities, as I alluded, to continue to increase the speed and efficiency of clinical trials. So what's really important is that funding not be a rate limiting factor for these initiatives. Oftentimes we don't know exactly what the funding need is going to be until the need exists. And so if we have to go out and raise funds once the need becomes apparent, then that introduces lag in the process and extends the timeline. We want to be nimble and essentially have resources to deploy the moment the need arises. And so to enable that, we've started 2 funds, a brachyury drug discovery fund and a therapy acceleration fund that allow donors to direct resources specifically to these areas of research that have the greatest potential to lead to near-term solutions for chordoma patients. But at the same time, give flexibility and nimbleness to deploy resources where they're needed most, when they're needed. So I think the take-home message here is that the current pace of research should not be taken as a given. Everything you've seen is only possible because members of this community have stepped up and contributed. And I think what we are seeing is truly an outlier in the world of rare cancer research, and that's because of the dedication and commitment of this community. So, huge gratitude to everyone who's made this possible. But also, it's not a given that this is as fast as we can go. The reality is we can go much faster. We've seen through CF Labs that the limitations on progress that exist within academia and industry can be overcome when we have the capabilities to pursue research that's inefficient or infeasible in those other settings, and to pursue research on our own. And given that that potential exists for those of us who are potentially in need of systemic therapies, really there is an imperative. We must go faster. As I shared earlier, I feel so lucky now to have had the opportunity to experience parenthood. I have a 4.5-year-old. We've been reading the book The Lorax, and for those of you who have kids, you might be familiar with this quote. At the end, it says, "Unless someone like you cares a whole awful lot, nothing is going to get better." It's not. That really resonates, and I think it is so true in this situation. There's no one else that's going to solve this problem for us. It's up to us. It's up to those of us who are affected by this disease, who have loved ones affected by this disease. This is no longer about hoping that perhaps one day those who come next will benefit. This is really about solving this problem for ourselves and our loved ones. And there's no one else out there who cares as much as we do. So I'm so grateful to everyone in this community for being a part of this mission, for making this progress possible. I invite you to get in touch, get involved, follow our progress. If you'd like to learn more, there's a webinar upcoming about CF Labs on June 21st, as well as our community conference up in Boston on July 15th. I hope to see many of you there. So thank you again, and I'll turn to questions now. Okay, so first question. If EGFR drugs stop working after several years, can different types of EGFR drugs be used? The short answer is we don't know. In some cases, tumors can develop resistance to EGFR through mechanisms that could be overcome with additional EGFR inhibitors. But this is exactly one of the questions we're trying to answer in CF Labs. So TBD. Second question here. How close are we to finding a drug that can control or stop the growth of chordoma? It's impossible to know exactly how close we are. However, I think what we are seeing is that there is an encouraging uptick in the number of therapeutic concepts that are moving from the lab to the clinic. As I mentioned, 3 new trials last year, 4 that are upcoming. I think that we will, in the next several months or year, find that 1 or more of the trials that recently completed has demonstrates some benefit to chordoma patients, but it's unlikely that that's going to be the entire solution. We're going to need combinations. We're going to need a sequence of therapies. So it's not going to be a drug that solves this. It's going to be a collection of drugs that solves this. And perhaps, each drug buys a little bit of time, and then the next drug buys more time, and eventually, chordoma becomes a manageable disease where patients can, for a long period of time, maintain their quality of life. But eventually, we're aiming, basically, we're not going to settle. We have to eventually find a drug that can truly cure this disease. And there's no reason to believe that with the right understanding and the ability to translate that understanding rapidly to clinical trials, there's no reason to believe that that's not possible. Okay. Another question. I don't think that I saw Epicentric seems very Nordic on the clinical trial systemic therapies. Are you able to elaborate? Okay. The systemic therapies list only includes therapies that are currently available to patients. So if there's a trial that's been done and there's no longer a trial open, there is not a compassionate use program, or it's not available off label, then it's not listed. So, you know, if and when those drugs become either approved, available through a compassionate use program, or a new trial opens, then they'll be listed. Okay, another question. Are there specific genetic factors associated with chordoma that contribute to the cancer being hereditary? The answer is yes. There are two genetic predispositions, at least, that are known of in chordoma. One is a very, very strong genetic predisposition, and that is having extra copies of the brachyury gene. That, as far as we know, is exceedingly rare. There's only been about 10 families in the entire world that have been identified that have familial chordoma. And in most of those cases, it's because of an extra copy of the brachyury gene. Most patients, the vast majority of patients, do not need to worry about that. There is another genetic predisposition to the disease, which essentially all chordoma patients have. And that is basically a different version of the brachyury gene. So within the population, there's several versions of brachyury, and one of those versions seems to be critical for chordoma to form. In other words, if you don't have that version of brachyury, you don't get chordoma. However, just because you have that version of brachyury does not mean that you do get chordoma. In fact, something like 30 or 40% of the population has that version of brachyury, and the overwhelming majority don't get chordoma. So I think the take-home message is, yes, there are genetic factors that could potentially predispose to chordoma, but from a practical standpoint, if anyone is worried about other members of their family or their children getting it, the risk of that is exceedingly, exceedingly low. Okay, how many patients are part of each systemic therapy trial? It varies. Most of these are phase 2 trials. Some of them are expansion cohorts, so they're a chordoma cohort on a larger phase 2 trial. It's anywhere from 10 to 50 patients on those trials. And so it's probably, unless there is a really, really dramatic response, it's unlikely that these trials, well, certainly the trials that have been done, but the trials that are ongoing, it's unlikely that those trials are going to lead to an approval. They're not designed to be what's called registrational trials. They're designed to be signal seeking. In other words, is there a strong signal here, a strong sign that the drug is having an effect, and then that could be used to guide off-label therapy. It could be used to change treatment guidelines, NCCN guidelines, et cetera. Okay, how can chordoma research benefit from AI, developments in AI? This is a really, really, really good question. In the past several years, there has been an absolute proliferation of new AI-based drug discovery approaches. And AI is a label that gets used to, that gets applied to a number of different things. So there's perhaps the more suitable term is computational drug discovery. So there are, for example, what's called virtual screening approaches, whereby rather than having to test thousands or millions of compounds in cells, which is very costly and difficult, now you can test billions or even trillions of compounds against a virtual model of, let's say, the brachyury protein, and see which ones bind. Now, I'm really happy to say this is being done right now by a couple, it's been done by a couple labs, and it's being done by at least one company. There are other approaches. There is kind of AI-assisted generative design, so whereby actually AI is assisting in the design of compounds and kind of taking, either aiding or replicating what a medicinal chemist would do. And similarly, those approaches are beginning to be employed on brachyury as well. The big caveat here is that all of these approaches, ultimately, they lead to a design for a chemical compound. And where the rubber meets the road is when that compound is actually tested in the laboratory. So AI still can't do that. You still have to take the compound that AI has helped design and test it in either against protein or in cells to see if it's having the desired effect. And this is a big part of why CF Labs is so important. So there's dozens of companies now that have relevant computational drug discovery AI-based approaches. All of them will require the ability to test the drugs that emerge or the compounds that emerge from those approaches in a series of experiments that are done in chordoma cells. Setting up those capabilities is time-consuming and costly and is almost certainly prohibitive for those companies. So essentially, it's a non-starter to apply those technologies to brachyury or chordoma unless we can make it turnkey or easy for those companies that have those technologies, or academic labs for that matter, that have those technologies to be able to have a way to test them. And this is what we're working on right now in CF Labs. And one of the things we're so excited about and is a top priority, we're building out a set of capabilities that are going to be made available to lots of different labs and companies. And I alluded earlier to these drug discovery partnerships. The idea is that basically we are the biology complement to the chemistry that's being done within various companies and leveraging various forms of computational drug discovery. So huge area of emerging opportunity. Okay. For gemcitabine, because the research has only been done in mouse models so far, what would be the best way to approach it as a treatment option to my oncologist, especially if my oncologist is not familiar with chordoma? So absolutely, mice are not people. So just because it has worked in mice does not mean that it will work in people. However, we have seen concordance between mouse models, results of drugs in mouse models, for example, EGFR inhibitors in mice and people. So, and we've also seen the reverse. We've seen drugs that are not effective in people also not be effective in the mouse models. So that is reassuring, but every drug works differently. And there's no guarantee that because it's worked in mice that it's going to work in patients. This is why clinical trials need to be done. So there's absolutely a risk in pursuing an off-label use of gemcitabine, especially before it's been in a clinical trial. However, this is a risk that oncologists and patients often choose to take when there are no other therapies available. And gemcitabine is a drug that is not experimental. It's been used in millions of patients for well over 20 years. So there's a lot of experience with how to use it. Really, really critical in any case to be treated under the care of a clinician who has experience with chordoma. And if there are any questions about how to find such a clinician, our doctor directory on our website is a great resource. Our patient navigators are a great resource. So please feel free to get in touch, support@chordoma.org, and we can help steer you in the right direction. There are a number of medical oncologists who do remote consults and who can partner with a local oncologist. So perhaps it's not feasible to get to one of the centers that has a great deal of experience. You may be able to be treated with a drug like gemcitabine, which many oncologists have experience with, under the guidance or with the guidance of a chordoma experienced physician. Okay, next question. Are any trials open outside of the USA, specifically in Europe? At the moment, none of the clinical trials that we are supporting that off the top of my head are available in Europe. The afatinib trial has recently closed. So that being said, there are new trials that are getting started, and so I would encourage you to reach out to our patient navigators. Just because a trial is not being supported by the Chordoma Foundation doesn't mean that it's not applicable to chordoma patients or open to chordoma patients. And the list of trials on our drug therapies page includes that kind of broader universe of trials that have been endorsed by our medical advisory board, but are perhaps not chordoma specific. So I would encourage anyone who's looking to check out that resource, and again, contact our patient navigators. Okay, has there been progress of Opdualag, Alimta, and Gemzar in treating chordoma that has spread to the lungs? So there's an ongoing, a couple of these drugs are in clinical trials. And some of the patients who have been on those clinical trials do indeed have lung mets. The results have not yet been published or fully analyzed. So I don't think that we can say conclusively whether they work or don't work for patients who have lung mets. But I think that there's every reason to expect that because these drugs are systemic therapies, they are reaching tumors throughout the body. And we have seen anecdotal cases of lung mets responding to different systemic therapies, both on clinical trials as well as off clinical trials. And so that is perhaps a hint or an indicator that there's nothing intrinsically intractable about metastatic chordoma. In other words, that drug can't get to it. But this is definitely an area of where there are open questions and further research is needed. Does Chordoma Foundation collect and aggregate off-label drug use from chordoma patients? Is there a way this information can be used outside a clinical trial for treatments? Great question. We do so in an informal capacity. So whenever we hear of an anecdotal response to therapy, we notate that, and we've over the years have generated a pretty substantial list of anecdotal responses, but this has not to date been done in a systematic kind of research setting. To do that requires having a research protocol and the ability to acquire medical records, look at MRIs, et cetera. That's a pretty big undertaking. In the near term, the best way that is being done is through a couple of ongoing protocols. Here in the US, there is a natural history study at the National Cancer Institute, whereby any chordoma patient can enroll at any stage of their disease, and they will acquire medical records. There's some upfront work to be done, but on a prospective basis, they will continue to collect medical records. And if patients have responses to drugs that are being used off-label, that's one of the key things that the natural history study is seeking to identify. There are a couple other ongoing protocols where responses to systemic therapy are being captured. I mentioned the master protocol in Germany. So a large percentage of chordoma patients treated in Germany are going on to the master protocol. And if they are treated with systemic therapy, that's being collected. And the great thing is their tumors are being collected as well, so we can actually start to understand the molecular determinants or predictors of response. But a big priority going forward, kind of one of the next frontiers for us, is to set up a kind of a systematic research registry of our own to be able to cast a wider net. So, the Chordoma Foundation, we're in touch with about 500 patients, or patients or family members, but representing about 500 patients per year. And in total, we believe that we're in touch with something around 90% of the US patient population, as well as many across the world. And so that provides a great opportunity to cast a wide net and perhaps pick up on signals of responses that might not end up in the natural history study or the master protocol, et cetera. So something that needs to be done. The challenge has been that is a big financial commitment. And once you start it, you can't stop it. So so we've needed to raise more funds and basically have the internal capacity to take that on. But for now, the best thing that people can do is, if you have a response to systemic therapy, get in touch with us. If there is a dramatic response, we can follow up with your doctors and kind of collect information about that case and share it with our medical advisory board. And that perhaps could serve as a hypothesis generator or justification for a future clinical trial. And then the other thing is to participate in the NCI natural history study. And there's more information about that on the website. Speaking of the NCI, there's a question here. Has the NIH been involved in any of this research? Absolutely. The natural history study is it's just an extraordinary undertaking and a massive investment on the part of the NIH that we are able to take advantage of as a chordoma patient community. So this is all funded by the government, taxpayer dollars at work. So, anyone who can or is inclined to participate, I would highly encourage it. It represents a very substantial investment. Additionally, I mentioned that we now know that brachyury duplication is responsible for many cases of familial chordoma. That was discovered with funding from the NIH, work that was largely done at the NIH, as well as with collaborators at Duke. And that same group has also pursued some very meaningful genomics research, which has been presented at previous research workshops and will be presented at the upcoming research workshop as well. And I'll also mention that there have been a couple clinical trials that have been done at the National Cancer Institute with brachyury vaccines and other therapies, and there's a new clinical trial that's getting started there as well. So we have been exceedingly fortunate to develop very valuable partnerships with a number of investigators at the NIH. Okay, Chordoma Foundation has done so much to help bypass inefficiencies in systems that incentivize profit notoriety over meaningful progress to patients. What is the current biggest hurdle that you see as impeding quicker development and progress in drug therapies? What can change? So on the preclinical front, it is at this point, the biggest determinant of the pace of progress is resources. As I alluded, we have a number of shovel-ready projects, target discovery projects that are just in need of funding. We have 12 projects in the queue through CF Labs that they could get started basically as soon as we have more capacity in the lab. We have a number of different concepts that have already been identified by our collaborators or validated within CF Labs that are just waiting to go into mice. And so it's really, how fast we go is a function of the resources we have to deploy. On the clinical side of things, to some extent, funding is a barrier as well. But there's also some infrastructure that needs to be built to enable trials to be started more efficiently. So, for example, a standard protocol so that the same, you don't have to go through the same protocol design and approval for every single trial. Ultimately, a lot of these trials look the same. And if if there was kind of wide agreement around a standard protocol, that could help trials go faster. There are various kind of opportunities around creating a master protocol. So you could basically slot in additional therapies into the same protocol, ongoing protocol, without having to restart a clinical trial each time a new concept is identified. So, more work to be done there. And then I would say, with respect to developing new drugs against brachyury, so eventually, we think that there is a sufficient market incentive to draw industry investment to brachyury. It is invariably the case that bringing a drug, into clinical trials and to the point of approval, when it's all said and done, is at the minimum, tens or hundreds of millions of dollars. There's no way that we're going to support that ourselves. So the question is, how far do we need to take the research? How much do we need to de-risk research to the point where industry incentives can take over. And having the capabilities I mentioned through CF Labs is a big part of that. Investing in the prize that I mentioned to have a set of brachyury tool compounds is really important. And just a note on why that's important. We need to be able to demonstrate, or more conclusively demonstrate, that there is a market for brachyury drugs beyond chordoma. So there's hints that it's involved in breast, lung, colon, prostate, about a half dozen tumor types. But because there are no brachyury tool compounds, there's never been a way for researchers who have the capabilities and experience and interest in those tumor types to conclusively generate the data or convincingly generate the data that indeed this target is important in those settings. Once that data is generated, the financial calculus becomes totally different for companies. And so as soon as we can get those tool compounds into the hands of researchers that study these other tumor types, and if indeed it turns out that brachyury is a meaningful target in those diseases, that's going to completely change the willingness of companies to invest and dramatically reduce the amount that we're going to have to invest in moving the ball down the field on brachyury drug discovery. Next question. Newly diagnosed, where can I find information on where to go for treatment options and oncologists to treat? How do I find out about trials and if I'm a candidate? So for newly diagnosed patients, exceedingly important to be treated by experienced chordoma physicians. Almost always, that's going to involve surgery and or radiation. There really are no drug therapies that are at the moment suitable for the primary treatment setting for newly diagnosed patients. We hope to get there at some point, but for now, it's really surgery and or radiation. And which of those or which combination of those is really is determined by a number of factors that are specific to each patient's case and really can only be determined by an expert physician or group of physicians. And it's really important to get multiple opinions. As much as there have been advances in therapy for chordoma and attempts at standardization, the reality is there still are kind of oftentimes more than one approach that could be suitable, and different centers have different opinions about how best to treat it. So first thing, get multiple opinions from chordoma experienced physicians. They can be found on our doctor directory at chordoma.org. You can reach out to our patient navigators at support@chordoma.org. And then as far as a trial, that can be found on the drug therapies page. But again, probably for a newly diagnosed patient, it's unlikely that there's going to be a trial that is open or suitable. But the good news is, in many cases, surgery and radiation can be highly effective. And if done right in the initial setting, as I mentioned earlier, maybe 40 or 50% of patients can be cured. And certainly many patients can achieve long-term disease control. Okay, next question. Is it possible to provide a list of off-label drugs that have provided some benefit in slowing or stopping the growth of chordoma? So that is on the drug therapies table. Version 2 will have an indicator of the results of the trials. It's not so straightforward to convey those because every trial is designed differently. They include different subsets of patients. So patients maybe who have just recurrent disease, advanced disease, metastatic disease. The endpoints of those trials are different. In other words, what they're trying to achieve is different, whether it's shrinking tumors, stopping progression, alleviating symptoms, et cetera. So there isn't a neat, tidy way of determining whether or kind of indicating whether the therapy has been effective. But we recognize that we need to do better and give some indicator. And so this is active, ongoing effort right now. And in fact, we just recently had conversations with our medical advisory board about how best to do that. And we have an upcoming medical advisory board meeting to address that topic. So stay tuned. But if you do have questions about specific trials or specific drugs, you can reach out to our patient navigators, but even better, reach out to a chordoma experienced medical oncologist. Okay, how can we inform the general community about this disease since it's a rare form of cancer? Yeah, it's a great question. So, I think that the reality is that those who care most about this are patients and those who care about them. So share what we're doing with your friends, with family, with colleagues. In particular, if there are philanthropists or foundations in your network for whom you think that the work that we're doing at the Kodama Foundation could be impactful, we would welcome the opportunity to be in touch with them. A lot of the progress that's been made has come through that exact route where a patient or family member either has a family foundation, knows someone with a family foundation, or is somehow connected to a philanthropist for whom what we're doing is interesting, whether it be because they care about Kodama or because they see what we're doing as a template or an exemplar for other tumor types. So those are really the kind of the universe of people that we'd really like to get in touch with. But we also are constantly seeking to broaden the universe of Kodama researchers and drug companies. So if anyone's connected to researchers of drug companies, please spread the word there as well. And then there's another question here: how do we get more funding as opposed to other cancers? Great question. The way to get more funding is to make it feasible for Kodama research to get NIH funding and to get industry funding. So unless a researcher can put forward a compelling research proposal, it's impossible to get funding from the NIH. So the vast majority of or not the vast, the majority of biomedical research is funded by the government, and it's not directed necessarily to one disease or another. There are some funding calls that are for specific diseases, and indeed there's some funding calls that are specifically for rare cancers. But the projects that get funded are not determined from on high. They are determined through a peer review process. And what projects rise to the top of peer review? Those projects that are being done by top-tier researchers who are pursuing cutting-edge research and who have generated preliminary data, who have demonstrated feasibility. All of those things require, they don't happen on their own. They require a lot of nurturing. They require an ecosystem to make it possible for top-tier researchers with cutting-edge ideas and approaches to work on Kodama. So what can we do as a patient community? We can help make it more feasible and efficient to do Kodama research. We can help attract the interest of researchers and companies, and we can reduce the barriers for them to be able to apply their research, their expertise and capabilities to this disease. And by doing so, that will allow them to apply for NIH funding. It will, in the case of companies, allow companies to make a business decision to invest in Kodama research. Because if it's so difficult to work on Kodama as to be essentially, impossible or too risky, then there's no way a company can justify investing. So it's really all about de-risking and making Kodama a disease that is conducive to high-impact research. And then the final thing that I'll say is that within Kodama Foundation Labs, while we are largely, at this point, it had been exclusively reliant upon philanthropy, we're rapidly getting to the point where we have a sophisticated enough kind of research operation and a track record under our belt that we could, in theory, successfully compete for NIH funding as well. And so I'm really, really happy to share and proud of the team that we've just actually submitted our first NIH grant ourselves. We'll know towards the end of the year whether we've gotten that. We've also submitted what's called SBIR, so small grants for innovative small business research, so new early stage biotechs that are pursuing new technologies. We've partnered with them to apply for federal funding to apply their technologies to Kodama and Brachyury. And there's a couple more grant opportunities coming up. So I guess the take home is it's our job as a patient community to make chordoma a disease in which meaningful progress can be made. And when that happens, other sources of funding will become available either from the government or from companies. I think that concludes our questions. I so appreciate everyone's interest and attention and support. Please do get in touch if you have any further questions, if you'd like to get involved. This is truly an unprecedented moment in our ability to influence our own destiny, even in a way that we didn't have the ability to do just a few years ago. Certainly I feel a tremendous sense of urgency and motivation. I know many in this community do. And I think more than ever, we have a chance of truly changing the outlook for this disease. So again, thank you. We'll look forward to continuing to work together and to seeing you at the next webinar and hopefully at the community conference this summer. Thanks so much.